Hi, dear folks. Today we are going to learn about the inventory models. So let's discuss about what is model. Model, a simplified description of a process to assist predictions. So inventory models, there are different inventory models for different kind of demand. So first we have the independent demand, and the second we have the dependent demand. Independent demand is the demand. Independent demand is the demand which is the demand of a product, which is the demand of a product. Like this marker is a product. So the number of markers required is the independent demand. And when we talk about the dependent demand, it is the demand which is dependent on the count of the independent product, like marker cap over here, nib, and its body. So all the caps, nibs will be the dependent demand. So let me reiterate, independent demand is the demand of a product. That can be the vehicle, that can be the pen, that can be the fridge, that can be the mobile, okay? And the dependent demand is the demand of a parts, components, and the other components which are required for any product. Okay, let's talk about the cost related to the inventory. There are different kind of cost related to the inventory, which is very important to learn. The first type of cost is the holding cost. Holding cost is the cost. Holding cost, the cost to keep or carry inventory in a stock. The cost to keep or carry inventory in stock. So it includes the housing cost, means the building rent, depreciation of a building, operating cost of a facility, warehouse facility, taxes you are paying, insurance you have taken. It also includes the material handling cost, equipment, lease, depreciation, power. It also includes the labor cost. Receiving, warehousing, security, and it also includes the investment cost. What does that mean? It means borrowing cost, taxes, insurance on inventory, etc. And it also includes the pilferage, scrap, and obsolescence cost. Since you have to hold the inventory for some time, so it includes. So overall carrying cost is one of the major expense. What is the importance? Let's talk about the importance of cost. Why are we discussing the types of cost? Because if you really want to reduce your operational cost, specifically in the inventory, so you need to understand the different kind of cost in detail, because devil lies in the detail. So the holding cost has the major weightage in the total cost. So that is why we discuss the holding cost in detail, that it includes the housing cost, material handling cost, labor cost, investment cost, pilferage cost, scrap and obsolescence cost. So it needs to be taken care of. The next is the ordering cost. So ordering cost is the cost which is incurs with the whenever you give the order to your vendor or supplier. So you require the product, but it incurs a cost like the expenses of your letterhead, okay, ink, cartridge, the people who are involved, or any application, software application you are using. So next we discuss about the setup cost. So setup cost, the cost to prepare machine or process for production. So whenever you want to produce anything, so you need to get the machine ready. Nowadays it is usually a witness that it is computerized, but still you require a good amount of time to get the machine ready, and it also requires the labor cost as well when you want to make the machine ready. The next is the setup time. Setup time, it is not the cost directly, but it increases your setup cost, because as much time you are taking to prepare a machine, it increases the cost, because you see, it is the opportunity cost as well, because you are paying to the labor. If labor hours are being used, if the machine is idle, so basically it is incurring the setup cost. So let's move ahead. Let's talk about detail about the inventory models over here. In inventory models for the independent demand, we are about to discuss in this lecture. So when we talk about the inventory models of independent demand, that is the demand of a product, of any product. So it addresses basically two questions: when to order, and how much to order. When to order and how much to order. So it's the date, you may say, the day to order, and what is the quantity of order. So both is how many days, after how many days, what will be the frequency, and what will be the quantity. So both information you get through the inventory models for the independent demand. So what do we have? We have three independent demand models. First is the basic EOQ quantity model, basic economic order quantity model, that is called EOQ model. So it is one of the very famous. And what are the benefits of this model? This model is used by many retailers, many wholesalers, many stockists, importers. Why? Because it gives you the order quantity which gives you the lowest cost, the lowest holding cost, the lowest ordering cost. So that is why it is very, very important for us. The next is the production order quantity model. So production order quantity model is a very effective model which gives us the optimum quantity, So optimum quantity is get through the production order quantity, that what is the quantity to produce, because whatever we produce, we need to keep it. We need to keep the inventory. So we need to know that what would be the quantity. Specifically, we also uses the quantity, like selling the product, and we also producing the product. So we need to know that what would be the quantity to produce. Quantity discount model is the last model for the independent demand. Quantity discount model is the model which tells you whenever you are given the discounts, because you see discounts are everywhere to improve the sales. So, but you need to see that what would be the quantity useful for you in terms of the cost. Because if you are incurring a lot of cost in the inventory holding, in the inventory ordering, so it does not make any sense to provide the services of a very in a very high cost. So you need to see, because your resources are limited, you cannot spend infinitely. So these models are very effective in reducing your cost. Okay, let's move ahead. Let's discuss about the first model, that is the economic order quantity model. Economic order quantity model, an inventory technique, that minimizes the total of ordering and holding cost. So you see, economic order quantity model, EOQ model, an inventory technique that minimizes the total of ordering and holding cost. So this is the first model we are going to talk about, and we are going to drive its equation as well, how we can get the optimum order quantity that minimizes the total ordering and holding cost. Why are we talking about the ordering and holding cost? Because most of the times our prices are constant, but the holding cost varies, and it is a very huge actually, and as well as ordering, as well as setup. So let's move ahead. So you see, it is useful. It is useful when inventory continuously builds up over time and traditional economic order quantity assumptions are valid. So when inventory is continuously builds, because you need to build inventory to give the to give the good response to the customers, to give the better services, to give the to fulfill your comparative strategy of responsiveness. It could be responsiveness, it could be the it could be the any of your competitive strategy you could have, but you need to fulfill the customer requirement. Okay, so in that you see there are few assumptions which we need to understand. Demand for an item is known. First assumption is demand for an item is known. You need to know the demand. Obviously the demand is not 100%, but the uncertainty must not be so much that you are unable to understand the demand. The second is the lead time is known and consistent. You see, lead time is known and consistent, because if the lead time, if the order and the delivery of the order is, whenever you give the order, the delivery is not on time, always late, so you cannot plan accordingly. So in this economic order quantity model, the assumption is lead time is known and consistent, that 4 days is given to the by the supplier, so the stock must reach to the destination in 4 days. Next is receipt of inventory is instantaneous. You timely receive the stock at once and complete one batch at once. Okay, there is no twice and thrice and 4 times that the delivery is being complete. The other one is quantity discount are not possible. There are no quantity discounts. Okay? There is no quantity discount. Only variable cost are setup and carrying cost or holding cost. Only variable costs are ordering and holding cost. So these are the variable costs, not other cost. So these are the assumptions that we do not have any other kind of cost. Stock outs are avoided if orders placed at the right time, because there are no stock outs, because you are giving the orders at the right time. Over here you see over here you see we have the this is the graph which is telling you about the total cost. Over here you see this is the ordering cost, which is reducing whenever you increase the quantity of order quantity is increased, the order cost is reduced. Why? Because of the great quantity, big quantity. Okay, so next is the holding cost. Holding cost is keep increasing whenever you get the bigger quantity. So these are the important costs we are looking for. So over here you see when we want to drive the model for the optimum quantity, so what do we need to see? We need to see what is the intersection point. So this is the intersection point, the point where the ordering cost and the holding cost both are equal. This is the point. And you see at this point the total cost is also lowest. Okay, so this is pretty important to understand. Now let's move ahead. Let's drive the equation. And in here you see first point is develop an expression for setup or ordering cost. This is the first step we would have to do. We need to develop the ordering cost expression in terms of the symbols, in terms of because we are about to develop the model that can be the representation telling us what will be the quantity. So it will be in the symbols. So whenever we want the optimum quantity, we just put the numeric numbers and we get the results. So we need to develop an expression that what will be the formula, how can we get the ordering cost. Next is the develop an expression for holding cost. Next we need to develop the expression. Expression is the formula and how we get the outcome of the holding cost. Third is the setup or ordering cost equal to holding cost. Then as per the graph we already discussed that we need to see that we need to equate the both expressions over here, the whatever we found from previously first step and the second step, we need to equate them. And the fourth is solve the equation for the optimal order quantity. Fourth is we need to solve the equation for the optimal order quantity. We need to find out what will be the optimal order quantity. So this is our objective over here. So over here you see these are the symbols over here. These are the symbols. So Q is the quantity, order quantity. Q is the order quantity. Okay. And Q steric, note it down, Q steric is the optimum order quantity. D is the annual demand. S is can be the setup cost or ordering cost. Okay, over here we are taking the ordering cost. H is the holding cost. Okay, let's move ahead. So you see over here, annual setup cost equals to number of orders placed per year. Into order cost per order. Whatever the order cost per order, because for example we are placing the 10 orders. So if $10 is the cost of every order, so 100 will be the annual setup cost or annual ordering cost. So basically both are the same. We take once because either we want the stock or we want to produce. Okay, over here you see number of orders placed per year can be found from the annual demand through the annual demand, that is D. Okay, that is the annual demand divided by the number of units in each order. The number of units in each order, that is representation of Q. So you see, whatever your annual demand is and whatever your order is. So when you divide the total annual demand with the number of orders or with the quantity of orders, so what do you get? Number of orders. Okay, with the multiply over here, you see ordering cost per order, that would be S only. Okay, that is the S. So we got the expression of the annual setup cost. Repeating myself, number of orders we get from the total demand divided by the quantity we orders. So if our quantity, for example, 400 and the annual demand is 4,000, so 10 would be the answer. So 10 will be the orders, number of orders will be 10, and S could be the cost, OP $10, so that would be 100. Its answer would be 100. Okay, let's move ahead. Annual holding cost. Let's find out the annual holding cost expression. So we know the annual holding cost is average inventory level, and multiply by holding cost per unit per year. Average inventory level into holding cost per unit per year. So you see, over here that average inventory level is Q by 2. Why Q by 2? Because Q is the most quantity we will be ordering. So I'm repeating myself, Q is the most quantity we'll be ordering. So over here you see, let me tell you this Q about the inventory level over here. So this is the quantity, the maximum order quantity, that is Q. Okay, so this is Q. Okay, and this is the usage, because you will be using the inventory. So you have got the inventory purposefully. So you see you are keep using it. So it is reducing. But this is the maximum quantity. Okay, so if we see, this is the maximum and this is the minimum. This is the maximum, this is the minimum. And if you see maximum and minimum by 2. So what would we get? Q by 2. So this is the average inventory on hand we have. And with the holding cost per unit per year, that is H. Now we have to equate the both equations, this one and that one, both. So you see over here, D by Q. You don't need to write into. It's same in mathematics. Okay, let's drive the Q, quantity Q. So we take this Q over here or multiply Q on both sides. So Q would be Q square. Okay, and that 2 would come over here or multiply 2 on both sides. So this side will be without 2 and this will be over here, the 2 will be here. H would be over here. If it is multiplying over here, it will be dividing over here. So you see Q square equals to DHS by H. So if we take square root on both sides, square root, square root on both sides. So what will happen? Q equals to 2ds by h. So this is the optimum order quantity. Over here you see this is the quantity which will reduce the total ordering cost S over here, and which will give you the quantity the quantity of the least ordering cost and the holding cost for fulfilling the annual demand. Okay, thank you very much.